Rest pause. The lifter presses a load to muscular failure. He rests for 15 seconds. Then he forces out 3 more repetitions. This is a common intensity technique. Gym folklore claims this brief pause recruits dormant fibers. Anatomical science reveals a different reality. Your nervous system experiences rapid fatigue during those 15 seconds. This fatigue dampens the electrical signal sent to your muscles. As a result, your high-threshold motor units remain inactive during the extra repetitions. The short rest fails to clear hydrogen ions inside the muscle cells. This local acidity prevents the calcium ions from binding to muscle proteins. You feel extreme burning in the muscle tissue, but you are generating less mechanical tension per fiber. Your brain detects this metabolic distress and actively decreases the motor signals. Rest pause accumulates high neurological fatigue for minimal stimulus. Supersets. You perform 2 exercises back-to-back without rest. The goal is to pump blood into the target tissues. This intensity technique saves time in the gym, but blood flow is not the primary driver of hypertrophy. Mechanical tension is. When you transition immediately to the second exercise, your heart rate spikes. This systemic fatigue limits your central motor drive. Your brain restricts neural output to protect the cardiovascular system from overload. Consequently, the muscle in the second exercise cannot generate maximum force. The electrical impulses from the motor cortex are dampened by the fatigue. The target muscle fibers remain understimulated because the heart is racing too fast. Your body diverts oxygenated blood away from maximum contractions to maintain blood pressure. You achieve a massive pump, but less structural adaptation. Drop sets. The lifter reaches failure on a lateral raise. He immediately drops the weight by 30%. He continues the exercise without stopping. Gym lore teaches that this extended set destroys muscle tissue for growth. Physiology explains a different event. The sudden drop in resistance reduces the mechanical tension on each muscle fiber. The mechanoreceptors on the muscle cell membrane only respond to physical load. When the weight drops, these sensors detect less tension, reducing the growth signal. You accumulate high amounts of lactic acid and hydrogen ions. Your shoulders burn intensely. But this burning is metabolic stress, not mechanical tension. While metabolic stress plays a secondary role, it cannot replace heavy loading. The reduction in resistance prevents maximum motor unit recruitment. Drop sets are highly effective for conditioning, but they are inefficient for generating pure mechanical overload. Myo-Reps. You perform an activation set of 12 repetitions to failure. You rest for 10 seconds. Then you complete 3 mini-sets of 3 repetitions. Each mini-set is separated by 5 deep breaths. This method is designed to maximize high-threshold motor unit recruitment. By staying close to failure, every repetition becomes highly effective. Unlike drop sets, the weight remains constant. This keeps the mechanical load on the active fibers high. The brief rest allows partial replenishment of local energy stores, but it does not allow the nervous system to reset. This means you remain at the threshold of maximum fiber recruitment. You bypass the low-tension repetitions of traditional sets. You achieve maximum recruitment in less than 2 minutes. Science supports this efficiency. Myo-Reps are one of the most precise ways to stimulate hypertrophy. Cluster sets. The lifter performs a heavy repetition. He places the barbell back on the steel hooks. He rests for 15 seconds. Then he repeats the process for 4 microsets. Gym culture warns that resting mid-set destroys the training stimulus. Biology contradicts this belief. Those 15 seconds allow your muscle cells to partially restore phosphocreatine. This chemical energy is the primary fuel for explosive contractions. By clearing metabolic waste, you maintain maximum power output. You lift a heavier load with better technical control. This translates to higher mechanical tension across all working fibers. Your nervous system avoids the systemic crash of training to failure. Each repetition is executed with maximum velocity. This high velocity ensures optimal recruitment of fast-twitch fibers. Cluster sets turn junk volume into high-quality stimulation. Eccentric overload. A weight is lowered slowly under high load. The lifter uses assistance to raise the weight back up. Then he resists the heavy downward force alone. Traditional training treats the lifting and lowering phases as equal. Anatomy demonstrates a massive difference.
Your muscle fibers possess up to 30% more mechanical strength during the lowering phase. During a controlled descent, structural proteins inside the muscle act like springs. These molecular springs resist the stretch and increase force generation. By overloading the eccentric contraction, you expose the sarcomeres to maximum tension. This mechanical stretch triggers longitudinal muscle growth. It specifically recruits the largest fast-twitch fibers. These are the fibers with the greatest potential for growth. Resisting the load stimulates deeper biological adaptation than lifting it. Interset stretching. The lifter finishes a heavy set of chest flies. Instead of resting, he holds the dumbbells at the bottom position. He maintains this loaded stretch for 30 seconds. Gym logs recommend total relaxation between active sets. Biology suggests a different protocol. This loaded tension forces the muscle cells into extreme stretch. It restricts local blood flow, creating severe oxygen deprivation. This state of hypoxia forces the muscle cells to signal for adaptation. When the stretch is released, blood rushes back, causing cellular swelling. This swelling signals the intracellular pathways to build structural proteins. The mechanical stretch activates the enzyme focal adhesion kinase. This enzyme triggers the addition of protein units inside the fibers. You are utilizing the rest period to continue the growth stimulus. Loaded stretching turns passive recovery into active hypertrophy.
Lengthened partials. The lifter reaches failure on a full-range bicep curl. He continues the exercise, but he only performs repetitions in the bottom half of the movement. Gym rules state that full range of motion is always superior. Anatomical science proves otherwise. Most muscle groups experience the highest mechanical tension when they are fully stretched. This is where the contractile proteins are aligned for optimal force production. The passive tension from stretching combines with active tension to maximize stimulus. By training only this lengthened zone, you maximize the stretch-induced growth signal. You bypass the weak, fully contracted portion of the lift. This allows you to load the muscle where it is strongest. Scientific data consistently ranks this technique as the most powerful stimulus for muscle hypertrophy. Your muscles do not care which technique is popular in gym culture.
They respond only to the physical laws of tension and recovery. The ultimate technique is not the one that causes the greatest burn. It is the one that forces your biology to build a stronger engine.